Good morning, students. Today we are going to see the topic heaps. It comes under Unit 3 Nonlinear Data Structures Trees. The objectives of this presentation are learning about the basic concepts behind the heaps data structure and to solve the problems using the heaps, that is the insertion and deletions. So first we have to know what is binary heap. So it is the efficient way of implementing priority queue. What is priority queue? It is a variation of queue data structure where the deletion is performed based on priority. The binary heap is simply referred as heap. Every heap should satisfy two properties, structure property and the other one is the heap order property. What is structure property means? The tree must be a complete binary tree. When we call the tree as a complete binary tree means every node should contain two children. Okay. But here we have an exception. For the bottom level, this condition may not be satisfied for the right side nodes, but anyway, it should be satisfied for the left side nodes. Okay, that is the tree must be filled from the left side at the bottom level. Okay, so this is called as a structure property, and this tree is not a complete binary tree because this tree is not completely filled from left. The node B is not having any children, so it violates the structure property. It is not a complete binary tree. Then we move on to the heap order property. So the heap may be the min heap or it can be the maximum heap. So what is min heap means? For every node X, the key in the parent of X is smaller than X. Okay. So if this condition is satisfied for all the nodes, then it is called as the heap order property. The reverse for maximum heap, that is always the parent should contain a greater value than X for every node in a binary tree. What is the use of this heap order property means? You can perform the delete min operation and the delete max operation, find min operation and find max operation in a quick manner. Okay, they can be performed. You can get the element, you can get the minimum element as well as the maximum element. You can find the minimum element as well as the maximum element in constant time. So that is the use of the heap order property. In the right side figure, this is not heap because it violates the heap order property. This is a min heap. So every parent must contain a smaller value than its children. For the last level, that is in the bottom level, we have two children 6 and 15, but its parent is having a greater value than 6. Okay. So it violates the heap order property. Now we move on to the basic heap operation. The basic heap operations are insertion and the delete min. The same way you can perform insertion and delete max operations in maximum heap. So we move on to the insert operation. What are the steps we need to insert an element into the heap means? To insert an element into the heap, first we have to create a hole. Okay, so the hole is created in the next available location. After creating the hole, we have to check whether we can place X in this hole without violating the heap order. If it's so, you can insert the element X there itself. Otherwise, we have to slide the element that is in the hole's parent into the hole. That is, the hole is moved up and the parent is moved down. Since the whole is moved up, it is called as a percolate up, and this process is continued until you find the right place for x. So we move on to the example. So this is a binary min heap because for every node x, its parent contains a minimum value. Okay. So I'm going to insert the value 10. So first I have to create the hole. After creating the hole, don't forget the hole must be created in the next available location. You cannot create the hole anywhere. Okay. It should be created in the next available location. And after creating the hole, we have to check whether 10 is placed in this hole or not. Okay, without violating the heap order property. So if I have inserted 10 in this hole, its parent must contain a minimum value because it is a minimum heap, but its parent is 30. So 30 is not less than 10. So this is not the right place for 10. So what I need to do, I have to move the hole up and the parent is moved down. That is 30 is moved down and the hole is moved up. Again, the same process is repeated. Can I place 10 here? Again, it violates the heap order property because its parent is 20. So 20 should be less than 10, but here it is not less than 10. So what I need to do? I have to move the hole up and the parent is moved down. Continue the same process. Can I insert 10 here? No, again its parent is 12. So it is not less than 10. So the hole is moved up and the parent is moved down like this. So since this is the last place and this is the right place for 10, 10 is inserted. Okay. So that's about the binary heap insertion operation. Now we move on to the delete min operation. What is the use of delete min operation? It always deletes the minimum element from the heap. Always the minimum element is found in the root. After deleting this minimum element, automatically the hole is created at that root. So in order to balance this, you can use this hole to occupy some element. Okay. So you have to move the last element x in the heap to somewhere in the heap. First I start whether x can be placed in that hole without violating the heap order property or not. If it can be placed without violating the heap order property, you can place x over there. If it is not, you have to move the smaller of the hole's children into the hole. Okay. That is, the hole is moved down one level. Since the hole is moved down one level, this is called percolate down. And this process is repeated until we find the right place for x. We will see with one example, then it will be clear for you. So this is a given binary heap and I am going to delete the element 10. So after deleting 10, always the root element is deleted in heap. Okay, whether it is a min heap or maximum heap, always the root element is deleted. So after deletion, root becomes empty. So I have to detach 30, that is the last element of the heap, from the heap. Okay, I have to delete the last element from the heap and it should be moved somewhere without violating the heap order property. Check whether 30 can be placed in this hole or not. So is this the right place? No, because every parent should contain a minimum value, but its children are 12 and 15. So both are having a lesser values than the root. So I have to move either 12 or 15, but I'm going with 12. Why? Because 12 is the smallest children. So it is moved up and the hole is moved down. Okay, like this. Since the hole is moved down, it is called as percolate down. Check whether 30 can be placed in this hole or not. Again, 30 and its children are 28 and 20. So you cannot place 30 over this hole. Which value should be moved up, 20 or 28? We have to go with 20 because it is the smallest children. 20 is moved up and the hole is moved down. Okay, so 20 is moved up. 20 is moved up and the hole is moved down. Now again I am checking whether 30 can be placed in this hole or not. So it can be placed because its only children is 38 and it is having a higher value than 30. So this is the right place for 30. Okay. So that's about the binary heap insertion and deletion. These are some sample gate questions. And Anna University questions can also be asked from this topic. They may ask you to construct a minimum heap or maximum heap for the given set of elements. Okay, so don't forget, we have to satisfy two properties for heap, structure property as well as the heap order property. So with this I am concluding this video. Thank you.